Last time we built a framework for thinking about decisions in the face of scarcity, which allowed us to develop, in my mind, one of the deepest ideas in social science. The production possibility frontier told us what Molly could produce, and these quantities depended on how much land she farmed, which could increase if she works more, has better technology, and rents more land. The slope of the production possibility frontier was how costly one good was in terms of the other. The seed that planted the forest of economics began when we introduced a second farmer, Andrew. We showed that when the two farmers coordinate their choices in ways that minimize the opportunity cost of the group, specializing in the goods they have a comparative advantage, and then trading for the rest. Both farmers in this case could be better off at the same time without needing to change how much land they work. It's difficult to overstate the importance of this idea. Specialization and coordination has shaped every part of society. Our world would just look fundamentally very different if this math weren't true. The field we call economics today came out of this transition out of feudal Europe at the beginning of the Industrial Revolution as the study of how to facilitate this type of cooperation. This math was famously developed by David Ricardo and others, sort of formalizing these ideas. But we're left with three remaining questions. First, we've only looked at two individuals. This makes it easy to find trades, but how might we coordinate trades when there are many individuals, not just two? The quick answer is that we'll begin to develop prices as a distributed coordination mechanism. To begin, instead of conceiving of opportunity cost in terms of goods given up, as in spinach for carrots, we're going to slip money in as a way of measuring Molly's opportunity cost. Typically, we've used spinach and carrots, but we can just multiply the quantity of carrots by the price of carrots. So Molly could sell her units of carrots at the farmer's market for the price in the market. And we can think of her growing more spinach as trading off the value of carrots. If this seems a little funny that we're introducing prices but we haven't established where they come from, that's exactly where we're going. All we're doing at this point is saying that money has some value, but we're going to close the circle on how we get there. So we've here redefined the opportunity cost of spinach as the money I have to give up to make it. This is what we call marginal cost in sort of loose terms, the cost of producing one additional unit. And you'll notice the resemblance to opportunity cost directly. We've just simply slipped money in as the units. So Molly has a marginal cost of producing spinach, and we can just ask her how much she'd be willing to produce at a range of prices. To produce more spinach, she would have to increase the land she would farm, which would itself require renting more land and equipment and hiring more help, all which requires more expense. So we have this graph here. On the vertical axis, we have price, which is different than our production possibility frontier, where we had carrots on the vertical axis. And then on the horizontal axis, we just have quantities of spinach. And then all we're going to do is simply look at the land devoted to growing spinach on Molly's farm and ask Molly a series of questions at a range of prices. How much would she be willing to sell? So let's say at a price of $4, she'd be willing to sell 1,000 units. And this is just fancy notation saying quantity supplied. This is how we denote how much Molly's willing to sell at any given price. So at this price, $4, Molly's willing to sell 1,000 units. So what we can do is take her price and quantity and plot it on the two-dimensional axis, which represents her quantity supplied at that price. And then we can ask her a range of prices, how much she'd be willing to sell. At $6, let's say she'd be willing to sell 1,500. And again, we can just plot this as a point on our two-dimensional graph, our price quantity graph. And then lastly, we're going to ask her at a price of $2 how much she'd be willing to sell. And we'll plot this 502 on our graph. Okay, so each one of these points represents a price-quantity pairing. It tells us at $2, for example, Molly would be willing to sell 500 units, and that's what this point here represents. So as the price of spinach has gone up, Molly has increased her quantity supplied of spinach at each one of these prices. This positive relationship between prices and quantities for sellers is what we call the law of supply, which we define as the quantity supplied of a good rises with its price. So we can represent all of these points. We could, go through and ask Molly at a range of prices how much she'd be willing to sell. But we could also just draw a line through these points, which would represent the supply curve. The supply curve, as we define it, is just the cost of producing one additional unit. But another way of thinking about it for now, and for our purposes for now, the supply curve is simply just all of the possible points that we could ask Molly. We've listed out gone through three examples, but we could do it for any penny increment. So for example, one possible quantity supplied we could ask for is $5.37, and that would give us a point on the supply curve. So we'll return to the marginal cost in a later section, but I just want you to see the general supply curve for the moment, that this is answering the question for us: how much is a seller willing to sell? And I haven't listed it here, but this is what we call the individual supply curve. We're going to come back and make that distinction in a second. But supply, would shift when we change the costs of producing a thing. So if, for example, the input prices into Molly's farm were to go up, say fertilizer became more expensive, then Molly's willingness to sell would go down. We would see a shift in the supply curve. And this vertical shift is essentially representing that the cost of production are now higher. If an input price goes up, it's more costly for us to produce. So at a given quantity, so let's say 1,000 units, where before we would, be willing to sell at $4, now because the fertilizer is more expensive, we have to charge a higher price. So fertilizer prices going up, as an example of an input price, raises the supply curve. Okay, and other changes can impact the supply curve. Technology is another one we've talked about in the context of the production possibility frontier. But if it turns out our technology gets knocked out by a storm, for example, our ability to produce spinach would go down. So just like with a change in input prices, a change in technology for the worse would raise the supply curve. We're saying at a given price, I'm now able to produce less than I could before. Or at a given quantity, it's now more expensive for me to produce. Either way you think of a supply shift is mathematically equivalent. So you can think of them both ways. But the approach I like to take is to primarily think of a shift in the supply curve in terms of changes in the costs of production. So we've increased the cost of production because our technology has gotten worse. And so we shift the supply curve up to reflect the higher costs. So to walk through an example here, going back to our two individual farmers, they each have their own supply curve. So we've talked about Molly's, but we could have talked about Andrew's just as easily. So we're just going to ask the three of them the same series of questions about quantities. So at $4, Molly's willing to produce 1,000 units. and Andrew's willing to produce 400 units. So on their individual supply curves, we can just plot these points. But in a market, we're not just looking at the two individuals on their own, we're looking at the sum of their spinach harvest. So if these are the only two farmers selling at the farmer's market, then to understand the supply curve for the entire market, we would have to add up both farmers' quantities. So this will put us at a point at 1400. So it's 1000 plus 400, and we just plot that, which tells us the market supply, the market quantity supplied at a price of 4. And then we can just do this for each of the other two prices we considered. So at a price of $6, Molly would produce 1500 and Andrew would produce 6. We add those two things together, which gives us the quantity supplied at a price of 6 for the market. And then we'll run through one more example. At a price of 2, Molly would produce 500, Andrew would produce 200. We plot those 2 points, and then we add them up together. Okay, so in practice, we don't do this type of addition in the way I'm showing you. What I'm showing you is just 3 examples of how we would construct the quantity supplied curves. The supply curve, the quantity supplied on the supply curves for the market. And just like we did for the individuals, we can draw a line through these points, which represent every possible quantity supplied for the market. This is what we call the market supply curve. And just like the individual supply curves, because we're summing over all of the individual supply curves, the market supply curve responds to the same shifters as the individual supply curve. So if we raise the cost of production, that shifts the supply curve up. If we increase our technology, that would make everything cheaper, so we would shift the market supply curve down. If we double the number of firms, then we shift the supply curve out. So you can take a look at at chapter 4 in the textbook for more information if you have questions about these things. But the last thing we're going to do when we talk about sellers is think about how good these exchanges are for sellers. This is what we call producer surplus, which is the seller's extra value from an exchange. So let's just list up one example here. So let's say we have a price of $5. The seller is willing to sell for $3. So the seller brings their spinach to market. They're willing to sell at $3. And they're able to sell at a price of $5. This is good for them. We know if the price is above their willingness to sell, then they're going to sell. And in addition to simply the fact that they're able to sell, they're also making a little bit of extra. And this extra is what we call producer surplus, which we can represent with this vertical bar, which is the difference between what the seller is receiving and what it costs them to produce. So it costs $3 to produce a bag of spinach, but they're able to get $5 for it. And that $2 difference is this extra value. And we usually think of this in terms of dollars. That's how we measure it. It's this sort of abstract notion of extra benefit from an exchange. Okay, and this responds exactly as you'd expect to changes in price. So if we were to raise the price to $6, then because the cost of this thing hasn't changed, all that's changed is this extra value to the seller. So the price went up by $1, so the seller's receiving an extra $1 of value. And so the producer surplus is now at 3 instead of 2. And if we were to lower the price to below the cost of bringing spinach to market, the seller seeing a price of 2 and knowing it cost them $3 would not choose to produce this thing. And so no exchange would take place. So I'm listing 0 marginal cost because they're not producing it. And because they're not actually selling the thing, they don't get any producer surplus. That's the key bit here. All right, So we could run through a bunch of different prices if we like, but this is the basic idea for producer surplus. But in a market, we sell more than just one good. So we're going to think about those vertical bars, but in the context of more than one exchange. So what I'm listing here is one possible algebraic relationship between prices and quantities that could represent a supply curve. We can see at a price of 5, we can plug 5 into this equation and solve for QS. So we're asking the supply curve, how much would sellers produce at a price of 5 by plugging in a price of 5? And then you can check this work on your own. You can solve for QS, which will come out to be 15. When this moves, when the price moves, we're asking the supply curve a different question. We're asking, at a price of 9, how much are sellers willing to produce? And as the price goes up, from the law of supply, the quantity supplied will also go up. Okay, so we have 35 units being exchanged in this market. We want to know the producer surplus in this environment. We have a price of 9, we have a vertical intercept of 2, and we have a quantity supplied of 35. So we need to take the vertical bar for each one of these 35 units and add them up together. So I'm going to plot these out on this graph, each one of these vertical bars representing one of the exchanges that's taking place, one of the sales of a bag of spinach. So one way of solving for producer surplus would be to go through and just figure out the height of each one of these things, which we'd have to be careful with the supply curve to figure out the height of each one of these things up to 9. That would be a little bit tedious. We'd have to go through and add up each one of them. Instead, we have a little trick. Similar to a Riemann sum, we're going to try to find the area of this triangle. Triangle is relatively easy to solve for. We're going to work with more complicated areas in the next couple of weeks. But we can easily find this area for the triangle. So producer surplus is the area of, essentially the area that's represented by these vertical bars. This one is a triangle. We can find the area of a triangle by taking the height, which is 9 minus 2, so the height, multiplied by the quantity, so how many things are being sold, and that's 35. If we were to just multiply the height times the base, we would get a rectangle, so we need to divide it by 2 to get the area of the triangle. So that gives us this thing, which is the sum of each one of these vertical bars, essentially. The producer surplus associated with selling 35 units. All right, and this thing responds to changes. So when the price goes down to 4, we have a quantity supplied of 10, and we can find the producer surplus in exactly the same way. We take the height of the triangle, which is 4 minus 2, and then we multiply by the quantity, which is 10, and then we divide by 1/2 to get the area of the triangle and not the rectangle. And in this case, producer surplus is 10. We'll do maybe one more example here. At a price of 8, we have a quantity supplied of 30, and we have a producer surplus of 90. It's 8 minus 2 is the height, the base is 30, and then 1/2 turns it into a triangle, which gives us 90. All right, so this is on the seller side. Next, before we can truly pin down where prices come from, which we've introduced and left floating, we need to understand buyers. We need to understand how buyers make their choices and their incentives and preferences. Once we bring all those ideas together, we can figure out where prices come from.